mention a couple of things. Basically, we are done. Well, we are not done, but we are not done. We have covered all the material that we are supposed to cover, right? And so we have this week, then the next week is Thanksgiving break. So there is no class at all the whole week, which is beautiful. And then we have one more week that I'm planning to use for review. And then the final exam on the 5th, right? So what is this class and the next one for? My plan, what I have done normally, and it usually works, especially for you guys, is to cover extra stuff that won't be on the test, but that is probably useful as you start planning your career. Chances are that you're in this class because you want to get a better job, and so talking about those things is usually mildly useful. Is that okay? However, we should not do that to the detriment of actually learning the stuff that we're supposed to learn. So, do you have any questions about any of the material we have covered? No questions? Cool, then let's talk about fun stuff, right? Throughout this class, you have learned to program in Java, right? Java is really cool. Where is Java used? What do we do with Java?
A lot of things.
A lot of things. Do you know of any actual application that's done in Java?
I think Minecraft's written in Java.
Minecraft was written in Java, yeah.
Yep. Java server pages.
Java server pages, right? JSP.
Which to make things really confusing, by the way, some people in Minecraft have now actually built a computer in Minecraft that's capable of running Java.
Ooh, that is meta. That is super meta.
Those computers are really, really slow though.
Yeah.
It's a bit abstract.
Java is cross-platform, which is really cool. Originally, it was proposed for embedded systems, so we could do embedded systems in a much higher level language than C. And then it became, oh, let's put Java applets on web pages, right? And then 10 years after, we realized, no, that's a horrible idea. Let's not put Java applets on web pages. However, Java became the not Microsoft of server technologies, right? So Java became, if not dominant, then close to dominant on the server side. A lot of server-side applications are run in Java, right? And then what do we do for the user interface, if there is a user interface? We do either JavaScript and HTML, or if you're doing Android, you do Android stuff, right? Android is actually Java, sort of, kind of. The UI parts, all the user interface stuff in Android is done in Java. Horribly, ugly, old, weird Java, but Java. For licensing reasons and things like that. So, how do we build user interfaces normally? What does server side and client side mean, right? What does that mean? You have your own machine, which is usually the client, right? And then you have some other machine, which is the server. I go to Bing.com. Of course, nobody uses that other search page, right? In fact, Bing is a verb. You Bing it. Yeah, okay. Never mind. And I search for stuff in here, right? And it gives me results. This is HTML, right? If I can figure out how the heck to do it on my Mac, I can look at the source code, more tools, developer tools. I can look at the source code. Maybe. Theoretically, this is
Without being so advanced,
it's
I can
somewhere.
source code.
It's somewhere in there. Ah, no. No domain. It's horrible. Ah! Index. And what it has is some horrible stuff in JavaScript or something like that, right? We go to a page that has decent source code, maybe. At least it should be less ugly. If we go to like bitbucket.org, right? We have source code. Maybe. Yes. Source code in HTML, right? When we click things, we are sending data to the server, which then usually gives us another HTML page. Does that make sense? What do I write this stuff is HTML. And HTML is not a programming language, it's a document markup language, right? It's text with this is bold, somewhere in there. Or this is blue or whatever. We have CSS for saying stuff that is blue and things like that. And then we have JavaScript for actual programming. Who in here has done some HTML?
Yeah.
JavaScript? CSS? No. Okay, prepare to get your mind blown. This stuff is actually amazing. Let's do this. And you didn't know it, but you have a, don't save, just kill everything. File, open, I'm gonna create can I open test one? Is this actual HTML file? Yay. Yeah, this is beautiful. Open file. Haha. This is more or less what HTML looks like. I have tags. Tags look like open and close, less than, some word, and greater than. And I open and close tags. This is a p tag, actually ends here, and I'm closing it here. Does that make some sense? I am doing horrible things in this example, because that's what I normally do with HTML. You have HTML. You have head and title and things like that. Head. And the title of the page is usually here, not on the actual page. Then I have the body, and I am going to skip this for a second. I have the body, and this says, here's the actual stuff. I can type stuff. These are input fields. This is a line break. This is another input, a button. These are paragraphs. You're supposed to do paragraphs, but not everybody does all the time. You can just do stuff like this. You can do stuff like H1s. The H is for header, and so you do H1, H2, H3, and so on. H1 is the biggest one, H2 is slightly smaller. Does this idea make sense? Yes, a little. Given that this is too simple, people started saying, oh, how can I make it look pretty, right? Computer geeks never said that, but graphics designers and things like that said, how can I make this look pretty? And they started stuff like H1, right? And stuff like B for bold. And all this stuff became a mess. So people started coming up with other ways of specifying that. We came up with CSS. And normally you wouldn't see it like this. You would see it as a pointer to a different file. But CSS lets you style your stuff. So in here I'm saying any button should have background color blue, which is why this button is blue. Does that idea make sense? You can spend definitely a year playing with all this stuff, right? It's not terribly useful, but if you're a graphic designer, you spend way more than a year playing with all this stuff, right? What do we do as programmers? What we do is we write programs that generate this kind of HTML for the most part, right? Usually you learn enough about the structure of HTML that you can print stuff that's not too terrible. And you have a graphics designer or a UX designer or something like that make it pretty. Or not. Usually you'd be surprised at how much abuse users can take. Actually, if you hear any of the old-timers talk about VI versus Emacs, you would not be surprised anymore. They're both horrible user interfaces, but once you get used to one of them, you love them. And that's kind of... there is a couple of other important things. One is we can actually do A for anchor, and that takes you to other places. And there is IMG for inserting images. And then there is lists and tables and a bunch of other stuff that you can do with HTML. So now I have this, and if I go, it will take me there. Does this make sense? Is this cool? It's a heck of a lot easier to learn than Java, but not, I mean, it is terribly exciting, but not terribly exciting, right? When you have a chance, go look at Coursera or Khan Academy or something like that. Probably not right now, over the break, right? You want to learn this stuff. You want to become mildly useful in HTML and CSS because this is what gives us food. And most of us have that nasty habit of eating 3 times a day. So this is what's gonna get you hired for the most part. Now, the really cool thing is JavaScript. It's nothing like Java. The only thing they share is the first 4 letters. Actually, they also share C. So a lot of the if statements and for loops and those things look exactly the same because they're both C. But I can, first of all, use it as a calculator. You have a JavaScript interpreter in your browser. You just have to figure out how the heck to get it in, right? It's usually in developer tools or something like that. Yes, my fingers are broken because it's different in every machine I own and every browser I have. So, in here is option Apple I. In Linux and Windows, it's Control-Shift-J if you're in Chrome, and I think it's F11 if you're in IE. Maybe, unless it's not.
It's one of the F keys. Not
Yeah.
accidentally.
But what can you do with JavaScript? Well, I can do stuff like this. My input here, right? I can use document.getElementById to get an element in my page. And so that allows me to manipulate the values. If I ask for the value, it's going to give me the value, and I can also set the value. And it changed here. Is this cool or what? And I can do whatever as long as I know how this works, right? Does this work? No. I cannot do style. You kind of need to go Google which one of the things you can apply to which elements and those kinds of things. Can I do background color? Ah. Oh. So I would do dot background. Sorry? What was it here?
Because you're using the IG name input.
Yeah, it's not. Oh, it's background color like that. Capital C and no dash. And I just made this thing blue. Isn't this cool? I can actually do. Ah! Doesn't work. Hash. Ah, perfect. I use red, green, and blue. Right? So red and blue gives you pink. You remember when they taught you in elementary school that red and yellow, like blue and yellow make green and things like that, right? They lied to you. Your teachers are liars. No, They gave you this subtractive model of color. It works when you're doing paint, right? Because of crayons or something like that. Because what those things do, right? What normal materials do is absorb light, right? So when you have blue, what you have is something that absorbs everything but blue. So that's why you see this thing as blue. Does that idea make sense? When you are combining lights, if you actually get colored lights, like floodlights, and you put them different color, then you'll see that it works differently, and that is this one.
It's magenta.
Yes, that's magenta.
Cyan, yellow, and magenta.
No, that is still subtractive.
No, that's additive.
No, cyan, yellow, and magenta is subtractive. It's ink. It's basically cyan, yellow, and magenta is what your teacher taught you in elementary school, except that they call them red. They called it red rather than magenta and blue. They called it red, blue, and yellow, right? And they told you those were the primary colors.
But if you switch that over to FFFF00, you get yellow.
Yes, but that doesn't happen on your printer.
Oh, no. Well, it's pigments.
But on your printer, the things are cyan, yellow, and magenta, actually. Oh. Yes, that is.
Because these are light emitters. So if you shine a red and a green LED, you'll get a yellow spot.
Exactly. Exactly.
So the colors and light working backwards for each other?
Yes. The elementary school model is not wrong, but different than this. So it takes a while, right? If you open Photoshop or any of those things, they let you play with colors. I do a color wheel.
Yeah.
I can even do something like that. Does that idea make sense? Some sense. We could even do stuff like this. Haha. Document.style. That should work. Make everything green. Everything yellow, but actually I tend to do. No, it didn't work. Document.style? Oh. Root node. Oh. Does this work? Ah. Red, green. That makes some sense. Yes.
What is this idea of node? Node.
Each of my things is a node in my HTML. Like this whole thing is one node. The opening of the tag, anything inside, and the closing of the tag. So I have this node, I have this node.
So you can have nodes that are embedded in other nodes, like how title is inside header.
Yes, which is why I do this stuff. Ah! Unless that thing appears. I may not even need this. Ha! I don't need to. So that defines kind of a tree structure that you can also access this way.
And what is the DOM?
The
That they keep talking about the
the DOM is the document object model. It's basically this mapping from your document to this object.
Which object? The JavaScript?
To the JavaScript, right? I have a body tag. I have document.body.
So it's the relationship between the JavaScript and the HTML,
Exactly.
the tags.
All the tags in your HTML define an object,
Okay.
right? Called document that has .body, .head, right? And I can do get. Text. I just changed this guy. So your HTML becomes an object.
So the JavaScript should be.
So the JavaScript can manipulate.
So if you can manipulate the HTML with the JavaScript, you don't really need the CSS, right?
You still need to know what kinds of things can you do, right? You still need to know that there's a background color thing and that exists because CSS defines it in a way. You still do need the CSS because normally you don't want to be manipulating. You can, but ideally, right? Document description is a lot easier to get right than actual running code, right? So if I have something static, it's a lot easier than running my code. So I do need CSS. I normally use CSS for doing this stuff, right? So you kind of, the bad thing about our current state of technology is that you need to learn an obscene amount of stuff. The cool thing is that most of that stuff is fairly easy and you are well on your way. You now hopefully have kind of, if this class was useful, it should have warped your brain. You're now doomed. You're not a normal person anymore. You think more or less like a programmer.
I say you're implying there that I ever was, but
Yes. Nobody ever accused me of being normal. But, now you should think differently, right? Which makes this stuff a lot easier to deal with, right? And so you should be able to do this. It should take you a weekend to be able to do some HTML, some CSS, and some JavaScript. Should take you a year or two to be really good at it, right? But you don't have to be really good at it. As long as you have kind of this kind of clue, right? And then, yeah, this is probably all you really need to know about HTML, CSS, and JavaScript, sorta, kinda.
What people gain using a framework like Angular that they don't, I mean, what there is in Angular plus
Let me
JavaScript.
actually let me show you something simpler than Angular. Angular is a complicated JavaScript framework.
Okay.
It is cool, but it's actually complicated. Let me show you a couple of things that can make your JavaScript much easier, right? One thing is jQuery. Let's go look at jQuery, actually. I don't need to download it. Please tell me where is the Hey you thingy. Yes. This is what I want. Max CDN. Huh. Okay. Beautiful. One of the things that I can do, I can include CSS. So rather than putting style, I can do style href equals and put a CSS file. And I normally do because that means that my code is cleaner, right? I can also do the same with JavaScript. Instead of style, I use the script tag. And that's including some JavaScript from somebody else. In this case, from a CDN for jQuery. What this gives me is this stuff. Gives me the $, which is just an identifier in JavaScript, as it is in Java, I think. But it does all sorts of things. So instead of me going document.getElement by ID and things like that, I can just do $, and specify that thing. So if I want to get this, which had an ID, right? So I can do $, hash this guy. What's the style? And I can even do this stuff. C1 was my class, so .c1 selects everything with that class, and then I'm going to apply it to everybody. No, I can't. Never mind. Lets you do all sorts of cooler stuff with this. Never mind. I lied to you. I seldom use jQuery, but jQuery gives you a lot of nicer stuff. It's not a framework, it's a library. And then I'm gonna show you the coolest things in sliced bread. And you'll see why you want a framework. Knockout is one of the nicest things in, where's the CDN stuff? Right now in JavaScript, I think. I'm loading and installing. You don't need to download and install anything. CDNs, yes, this is what I want. Oops. What this gives me is the ability of doing defining my objects here. Sorry, let me go look at the documentation because normally, this is what I want. Okay, I can do Bob. then what I'm gonna have here is ko.apply main view model. And in here, if it all worked, I should have Bob somewhere. No, semicolon. It's not ko.apply, ko.apply bindings. And I have this guy here that's coming from this, right? Let me eliminate other stuff. What do I use? ko.observable. I have this, right? But then I can just do main view model dot name. Oops. And it magically just changed. So what I can fairly easily do with something like Knockout is define my model as just a JavaScript object, right? Use the bindings to see how it gets printed on the screen, right? To define how it gets printed on the screen. And then I am just in my programming doing calls to the server and changing values in my object. And the display gets done automatically. Angular is a more complicated framework that defines this stuff, gives you a way of mapping your data to the screen, but also kind of promotes a particular way of sending requests to the server and things like that. So the boilerplate stuff, right? The entry level fee for Angular is a lot higher than for Knockout. Knockout is just include this thing, right? And then in here you create your things are observables, right? I can do stuff like this. I don't even need this stuff. I can just do data bind. Oops, no. Not text, value. Input have values, I think. Ah, yes. Change it here, it gets changed here immediately. I can do a lot more fancy stuff with this. Basically, my templates can do for loops and print different things, or usually go through a list of things and display every element in the list by using a table in HTML. And so you still need to learn HTML and CSS and JavaScript, but it makes your life so much easier. Does that make sense?
What is CSS?
CSS is this stuff.
It's like writing in C. Is that
No, it's cascading style sheets. It's defining background color or something like that. It's making stuff look pretty. But you can specify size on the screen, and you can specify the size in percent points or something like that, and do all sorts of fancy stuff to make it look pretty.
What's the difference between a library and a framework?
Those things are whatever. What am I selling you today? But my idea is you call a library, a framework calls you. To me, that's the main difference.
What do you mean?
Like, if you think about it, when I'm doing jQuery, I call $.whatever, right? Whereas in here, I'm more specifying this, right, gets called by the framework, not by me. I'm never explicitly saying call this. So the framework is going to be calling stuff in here. I give stuff to the framework, and the framework does whatever it wants with it in a way. A lot of the UI frameworks are frameworks. To your Android, when you create an Android application, you kind of define your pieces, and then Android decides what to do with them and how to display them. When you create a Windows app, it's fairly similar. And if the framework tends to call you, not that. Libraries are a lot easier to deal with than frameworks because you are in control. But frameworks like this make your life so much easier, right? Now, this is the client side, right? And on the client side, I normally don't use Java. You could. Some people do. Java has a UI library, and so you can make your browser run Java and run Java applets. But now, almost nobody does, right? It's not that common anymore. What do I do on the server? What does my stuff look on the server? Actually, unless you guys prefer to play with just JavaScript and stuff, I was gonna show you what it looks like on the server and what happens with server stuff. To kind of tie the whole thing together. I cheated because I'm terrible. On the server, there is many ways to do this stuff. In Java, one of the main ways is to use the Spring framework. The Spring framework does all sorts of magic for you. It's officially a dependency injection framework, not even an MVC framework, but it does obscene amounts of magic for you. So much so that it's a horrible pain in the neck to get started with it, right? cool. Let's see. This is the Spring framework. Let's build a better enterprise. Okay. JVM systems, build anything, run anywhere, rest assured. What the F can I do? Oh, guides. Okay, that should be cool, right? Getting started guides. Okay, that's cool. Building a RESTful web server, schedules tasks, consuming RESTful web service, building Java projects with Gradle, building with Maven, accessing relational data, right? Look at this. These are the getting started guides. Right? Yes, you are embarking on a lifelong learning process. You don't need to learn all of this stuff, right? But Spring is actually complicated. I've been using Spring in Angular for about a year, and I'm still not an expert, and I still have kind of a love-hate relationship with it. On the other hand, it is very powerful, lets you do really cool stuff fairly quickly. We're going to learn a couple of pieces there. You need a gajillion libraries. So somebody, or a bunch of somebodies, came up with this idea of Spring Boot. Spring Boot Spring, the idea is that you can use all the pieces independently. There is several times, there is 2 or 3 different libraries for doing the same thing, and you can pick whichever one you want. Spring Boot says, no, I'm going to give you one way, the one true way, right? Which is not quite true, but helps you get started a lot easier. They also figure out how all the libraries tie in together. So Spring Boot puts one release, and that has a given number of every given library. And they make sure that they all work together, which is a lot nicer. Does that make sense? Still not quite one thing, it's like 10 things, but hey, it's 10 rather than 100. So, what I am doing in my Gradle file, did we ever talk about Gradle files? No. Okay. We have Java files, right? You have a Java file, whatever.java. How do you compile it? You call javac, the Java compiler, right? And that produces a whatever.class, a class file. How do you make it so that you include all the libraries that you need? Who knows? What do you do with your class files? Well, I can zip them. If I put them in a zip file and I call that zip file a jar file, it sort of works. But it's a pain. And you can put your libraries, right? Doing that manually is a pain in the neck. In the 80s, when Ricci and Kernighan and all those guys came up with C and Unix, they came up with make. What make does is it looks at all your source files. At the time it was your .c files instead of your .java files, right? And then it looks at which ones have been compiled and which ones have not, and compiles the ones that you need to compile, and then it gives you steps for putting it all together, right? Linking. Gradle is similar. It does all of that stuff for you. It's actually an offshoot, sorta, kinda, of Maven. About 10 years ago, 15 years ago, people discovered that XML files allow you to have kind of a general syntax, which is really nice. Allows you to represent trees in text and not fight about syntax. And then for about 5 to 10 years, everybody started defining everything in XML, which was terrible, because the fact that you can't define a syntax doesn't mean that it's a good syntax, right? I hate XML with a passion. Not everybody does, but Maven uses XML. Gradle uses Groovy, which is a programming language that runs in the JVM, for defining these things. And so it looks a lot nicer. It still looks kind of like trees, but it is based on plugins. I'm applying the Java plugin and the application plugin. And this basically tells it where the source files are going to be and how to put them all together. I'm applying the idea plugin, that's so I can generate this project files for IntelliJ IDEA. If I wanted to do the same for Eclipse, I would apply the plugin Eclipse. Sorry? One more P. Apply. 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 I don't know. I define my main class name. One weird thing about Groovy versus Java is that strings can be single quotes or double quotes. I tend to use single quotes. Because I find them easier to read. A lot of people use double quotes. But, I'm defining my main class name. That looks like a Java class because it is a Java class. Gradle is going to go download my dependencies, so I need to tell it where to get them from. Maven Central is a server that hosts oodles of jar files. So that's what I'm telling it here. Go get this stuff from Maven Central. Then I specify my dependencies. In order to test, go get JUnit 4.12. In order to compile the thing, go get Spring Boot Starter Web, which gives me a bunch of stuff, and then Spring Boot Starter Timeleaf, which again gives me another bunch of stuff. Timeleaf is a template library. We'll see in a second. We'll see in a second, maybe. And this stuff is not, yeah. This stuff is actually not in it. So I have my main application, right? Phonebook app. What do I do? Define the package, import stuff. I use this annotation to say this is a Spring Boot application. I have my main file, and Spring is a framework, so it's going to run me. So I tell it, go run me. Phonebookapp.class, the same guy, right? One of the things that it's going to do is going to go look at my other classes and see if there is something special about them. And so it's going to come look at this. When we started talking about web stuff, we called it Model View Controller. Why? Because the Model View Controller application, model of applications was really cool in GUIs, and so we wanted to use the same terminology. It means something completely different. But it's still sort of the idea. You have a model. You have something that represents your data. And then you have a view. You have a way of displaying your data that's independent of your model, rather than combining them together. So you could have different ways of looking at the same data. Does that make sense? And then the controller kind of orchestrates everything. We still more or less use the same idea. In a Spring application, the controllers are the things that talk over the network. And we normally use HTTP. You can do other stuff, but I'm saying I'm a controller. I'm saying enable auto configuration. So if somebody is trying to discover, right? Look at me. I define my class. This is the cool thing. I'm saying map this function to this request. So basically, whenever somebody calls this path do this function and return the result. This add response body says return this actual thing instead of go pass it through a view. This is my function, and I'm returning this. So if I were to be here and run it, which I'm doing, it normally runs on 8080. So I can come to localhost :8080, which is the root, and I saw this thing that I returned. Does this make some sense? I can do stuff like this. Let's do more stuff. I can do more magic like this, add path variable. I'm just annotating my variable string name with this magic, and it is mapping to this thing. So instead of hello world, I can do hello plus name. If I want to kill this guy and run it again, because I just changed it. There are ways of making it auto reload, but I didn't have the time to figure that out. One more thing that you include and then it works. But now, if I just go to the place, I will get an error, right? Because I don't have a mapping for this route. Oops. Oh. Why? But I can come to hello. Slash Orlando, and that gets mapped to the name here. Oh, I still have the mapping for the root, that's why it was there. So basically this function gets called with Orlando as the name, and so it returns this, and that is what I see. Isn't this cool? What can I do with this? Well, whatever the heck I want, right? It's just getting the stuff, right? I could return whatever, right? I could do stuff like add A, B, maybe it will even work. I'm now saying that I return int. Yay. or whatever, right? Now I have full Java code and I can do whatever the heck I wanted to do. Does that make sense? There is one more thing that we'll definitely not cover, which is how to access databases. If you guys are interested, we can look at them next class. But one other thing that I wanted to show is this idea of views. So I have another thing, which is H3, map to H3, right? I'm passing a model, which is a weird thing, from Spring. I'm also passing this path variable name. I am adding 2 attributes to my model. As welcome, I have bienvenido, which is welcome in Spanish. And as name, I have whatever I got from here. I'm returning H2. Notice that I don't have add response body. So what Spring is going to do is it's going to go look at my templates to see if it has a template for H2, and it will find it here. In this template, I do th:\text $welcome. This is substitute the variable welcome, right? And this substitutes the variable name. So if I come here and look at H3, Marcelo is prints bienvenido instead of welcome, and it prints Marcelo as the name because that's what I'm passing here. Does this make sense? So you basically get horrible things because my IDE is doing dumb things, but you can do 2 different models of building your application, right? One is build it always on the server side, right? And use this to produce HTML, to produce whatever you wanted, right? You don't need any JavaScript. You still need to learn HTML and CSS, but you don't need any JavaScript, right? The other model is do it as we started and as we did the add and those, where you are basically just sending JSON back to the server, and then your actual application is done in JavaScript. You click a button in your JavaScript, and that sends a request to the server, gets the data back, and figures out how to display it. Does that make sense?
So what you're saying is that the Java on the server side can read JSON?
On the server side, you could read JSON, but you normally produce JSON for the client side.
So Java can read XML and JSON?
Yes, of course. There's libraries for reading and writing XML and JSON and 7 other texty notations. Does this idea make sense? You just got the whirlwind tour of writing web applications. The only thing that is missing is communicating with databases, right? What we normally do in our day-to-day work for the vast majority of programmers, at least 70–80% of us, right, is doing this kind of stuff, reading the data and then sticking it into a database, or building data out of a database and displaying it in pretty HTML. That's kind of the programming part of it. The really hard part, which we normally don't cover because we do the easy parts in school, is understanding what the heck the user wants. And that is what a master's in software engineering might teach you. But usually that's what 10 years in industry will teach you. You're starting, you only need 9.5 now. It's kind of you get it by talking to people and figuring out, and normally you learn your particular domain, your particular company and things like that. This is kind of what we do every day. What should we try to do on Wednesday? We can try either doing GUIs in Java, like normal GUIs like swing and that kind of stuff, or putting this together with the database. What would be more interesting to you guys? Or covering more maps or something like that.
No Java, please.
Sorry?
No Java, please.
Java GUIs are not practical, but seeing GUIs in general is a good idea. Does that make sense? I wouldn't write a GUI in Java, but it's probably a good idea that at some point in your life you figure out how to write GUIs with the normal programming language as opposed to this way. This way is the preferred way, but sometimes the other one is useful. Yeah. So no Java GUIs, we do databases.
I don't know how to do any of those things, so pretty much
Either
all of
one
them
is
will be
useful.
useful.
Cool. Then I will see you guys on Wednesday.